topic 1-4, graphing inequalities in two variables. This can be referenced with our Holt textbook, chapter 6, section 5, on page 414. Alright, you're probably going to want a ruler if you want to try to make accurate graphs. So grab a ruler and let's look at some of the, I think I'll cover this up. Let's look at the first ones. If you've got a graph of y equals 2x minus 3, determine where this would be. Y is less than or equal to 2x minus 3. So for this one, change pens, you've got to decide where your answers would be on this point. So first you're going to graph it. You're at a -3. Always remember, let's review that this number at the end in y equals mx plus b, this is my b. Alright, this is your y-axis, and this is where you start on the y, let's see, intercept. This was be int. Intercept. This, number 2, is your slope movement. Anytime this is a whole number, put it over 1. This is your slope, and that is your rise movement, the up or down movement, over the run, which is a left or right movement. Again, you may want to stop right here if this gets real confusing, because we've got to know how to graph linear equations before you go really any further with graphing inequalities. So if this confuses you, make sure you ask your teacher to go over graphing regular linear equations first. But this one, however, is shown lots of points. Really 3 points is good. But if you start at a -3, shown with the pink, and the slope movement is 2, we know we go up 2 over 1. You're walking up the steps, making your slope. Up 2 over 1, up 2 over 1, continuing on out. Now I do want you to at least plot 3 points on a line, and then using your ruler, when you draw this line, connecting those 3 points, make sure you come all the way through the boxed coordinate plane. The reason is when you start shading, you want this line to have hit the outside of the box up here and the down below this box down here. Okay, so you're choosing 3 points on one of either side of the line and putting them into the equation and checking. So let's pick just 0, 0, 3, -1, and 4, 5. If I pick these points, plug them in, you might pause this because I'm not going to write all this down several times, but you would want to write them down. You're trying to decide which ones would make this a true statement. If you were trying to say that the graph is less than or equal to this, then the shading for this is going to be below the line, and the line itself has to be solid. So I reviewed that in 1-1 with my little example. I think I've got it right here. If you want to refer back to this little guy, if you have solid lines, then it's solid circles when we do just a number line graph, but you're going to have solid lines on a coordinate graph. If it shows an inequality that's just greater than or less than, open circles on a number line graph, and on a coordinate graph you have dotted lines. So if you need to refer back to these little notes, then go ahead and do so. But do know that if it's a less than, you're reading from this variable. If it's a less than, then you're actually going to shade below the line. So again, they graphed the exact same one in this graph, and they did the same one here. Starting at a -3, up 2 over 1, up 2 over 1. Draw your solid line through the whole coordinate plane, and then take your pencil, I'm going to use green, and you're going to shade below. Again, if you want to get even some colored pencils from your teacher, you can do this with colors, because this is the area that's shaded. So make sure you remember these things. Greater than or equal to y will be a solid line because of this right here, and then it's shaded above the line. For a less than sign, y equals less than, it would be a dotted line with shading below. just a greater than is a dotted line with shading above. So take a minute, fill in these notes. But I'm going to go ahead and you can pause it if you need to. Let's go on to solving some more inequalities by graphing. All right, look at this one. First, you want to get the equation into the y equals mx plus b. If you need to, make note on the top of your page, y equals mx plus b, and if it helps, you can go through each one of these and highlight the b, because once you solve for a linear equation by rearranging, you're going to start on this y-axis. So I'm just overemphasizing where you're starting, because your starting point, unless it's an x equals something, will always be on your y-axis. So this last one's actually a good one to go over too. Okay, so your starting point after you've rearranged. Again, if this gets real confusing, go practice rearranging a few more linear equations with your teacher, because I'm going to kind of walk through this one fairly quickly. You want to isolate the 3y. You're moving the 2. Once it moves across an equal or an inequality sign, it's its opposite, so it goes away. Do not combine the 6 and the 2x. They have different like terms. This is a constant, and that has an x as its a coefficient of 2. This actually is your slope. The mx, that's that portion right there. So 3y is greater than 2x plus 6. To get the y alone, again, your key is to isolate your y. You want to divide by, you add opposites, but always divide by the same. And you're dividing it everywhere. This has just been cleaned up. 2/3 written by itself. Put the x all by itself. 6 divided by 3 is 2. Where am I going to start? Starting at the 2. Walk up 2 over 3. Up 2 over 3. Again, 3 nice points will be plenty. Please use a ruler. Draw a dotted line. This one would end up being dotted because it shows just a greater than. Since it's greater than, it's shaded above. Rearrange this one. Look closely at how everything's been first moving away. Sometimes I teach students to box in the y. Even over here, if you boxed in the y, you knew what you need to move. Because if you box the y, you see something next to it that shouldn't be there because it needs to be alone. So then it moves to the other side by subtraction. The 3 is then divided away from the y by division. Dividing by the same, that's why you have to make sure you divide by a negative, because you want this to be positive y, not negative y. Starting at a positive 2, walking up 1 over 3. Up 1 over 3. Good 3 lines to make a solid line, because this has a solid showing equality, and this one would be shaded below. So take a minute to look at these though. This is very important to go over when you have an equation that's only y and a constant. There is no slope. A 0 slope goes straight across this way. A slope that is undefined goes up and down, like I'm showing my ruler. So these 2 lines show what it would be if it's just a y with no slope. A 0 slope goes straight across through the y-axis, being my b, and at that, every single point is at 3 along that. Again, it's showing greater than, so it's everything above the line. And an x value is a straight up and down line because it's at the x value of a -4 every time you plot a point. I would walk to the -4 and go to the -4 and stay at 0, or walk to the -4 and do a negative movement. So if there's no slope at all and it's x equals something, this is actually an undefined slope, not a slope of 0. It is a solid line because this is shown equality, and it's everything less than, so it would go down the number line. Think about these values as being negative continuing this way, positives continuing this way. So if it's a less than, it's going to be shaded to the left. So then you're asked a few questions. On question number 1, which is this one right here, which of the following would be solutions? So look at each one of these, and if you can plot that point, 4, 8, I can walk over 4 and go up 8. I'll be in the shaded area, so that's a solution. A 1, 0 is outside the shaded area, so it's not a solution. A negative 6, negative 2, 1, 2, 3, 4, 5, 6. Be real careful, because that's negative 6 and that's negative 2. That, I'm going to put a little star by this. The reason it's not a solution is because the line is dotted. So make note, even though this hits the line, if it's a dotted line, it shows that it has to be, in this case, greater than, not equal to. So if it's on a dotted line, it's not equal. It would have been if it was on a solid line, but not that. So be real careful. So check each one of these two and note that they will not be in the shaded area. That concludes 1-4.